Hello student, today we are going to see CBSE sample paper which one is recently released 2020 and 21. In science we are going to discuss only a physics, okay. Actually it's a 3 hours paper, 80 marks. So the physics question we are going to discuss what is asked in a sample paper. So it is 2021, the current batch which is going to write in a board exam, okay. The section A, so question number 4 is a physics question. Why does the sun appears white at noon? Okay, at noon time why the sun is appear it is a white color. So this answer we can take it as a when the earth so we are here when at noon, exactly noon, the sunlight will be perpendicular to our head, okay. So when the refraction is happen at 90 degree, so it less deviation will be produced, okay. The another thing, less scattering also is one of the answer, okay. The answer key is given as a less scattering at noon time. That is the cause will get as the white color, okay. In case more scattering is happen, we'll get as sun is a red color, okay. Medium like average scattering is happen, we'll get a sky as a blue color. Sky as a blue color because of scattering of sunlight, okay. Morning and evening sun appears red color because the scattering will be more, so blue deviate away and red reaches, okay. At noon time the scattering will be very less. That is the reason at noon time the scattering is less. That is the reason sun appears white in color, okay. There is less scattering will be produced, okay. The question number 4, why does the sun appear white at noon? Because the scattering of the sunlight, okay, the less scattering of the light, that is the reason sun appears white color at noon time. The next question, so fifth question, it's about the lens. Both the spherical mirror and thin convex lens which will have the focal length is minus 15 centimeter. What type of mirror is, what type of lens is? So when they are given as a minus, negative, okay, so the lens is also concave and mirror is also concave. Lens is concave, mirror is concave, lens is concave, both is the concave. So concave only have the focal length is a minus 15 centimeter and minus 15 centimeter. So both is the concave. The question number 5, the lens which is produced minus 15 focal length, what type of mirror and what type of lens? The mirror it's concave, lens is also concave. Concave mirror and concave lens. This is going to be a negative focal length, okay. The question number 6, the image is formed by a concave mirror is observed at a real inverted enlarged than the object. Where the object be placed, okay. So the question is asked, it is a 1 mark. You have to give the exact location where the object has to be placed. The image formed by a concave mirror is observed to be a real, inverted and enlarged than the object, okay. Inverted, real, so the mirror is concave, so it is a real image will be produced. We can see in between it's a C and F, okay. Otherwise we can see at C in between C and F, okay. The image will be produced magnified at the point where the object is placed in between F and C. So this will go like this, center ray, and it will be reflected in the same angle. It's going to produce as the real inverted magnified, okay. So I got the image place, object place is the in between C and F. So this answer, it is between F and C. The next thing, name the part of the lens through the ray of the light passes through without suffering any deviation. So when without suffering any deviation, at when the light is passes at optical center, it's one of the sign convention, it undeviatedly passes straight. Otherwise the same point you can take it in a principal axis. When it started at it travel through principal axis, that time also it has to passes in optical center, okay. The ray which is passes at optical center, so which is going to be undeviatedly go straight. This answer we can give as a optical center for the lens. So undeviatedly it will be passes at center, okay. It will be straight, okay. So the sixth answer, second one, either or any question you can try, the second answer will be undeviatedly passes straight without any deviation. Question number 7. So question number 7 is given. So this is a Faraday's experiment setup, okay. The key is first initially closed. When the key is initially closed, so electric flux will be increasing in a primary coil. This is a primary coil, it is a secondary coil, okay. When the key is inserted, the current is going to be flowing here, okay. So current is flowing here, so slowly magnetic flux will be increased in a secondary coil also. Okay, so the galvanometer is going to deflect as the one side. Then what they are doing, okay, when what will be happen, okay, when we switch on this key, the magnetic field will be increased, okay, when the current is become as a saturated, current usually 1, 2, 3, 4, 5 till 10, we'll take it as maximum is 10 ampere battery, this is, okay, so till 10 ampere is flowing, till 10 ampere the magnetic flux will be increasing. When the flux is increasing, galvanometer will be deflecting at one side, okay. After some time, the galvanometer will be showing the current as a 0. That means there is no flux, flux will be changing, magnetic field will be 0. There is no increasing, decreasing magnetic field, okay. Then they are removing this plug key, they are taking out this plug key, okay. So the flux will be decreased, the galvanometer will be deflect as the opposite side. So I'll repeat again, when the key we inserted, the current is flowing, slowly it will get increased. So when the current is increasing, it is called electromagnetic principle. So slowly the magnetic field will be increased, the magnetic field will be transferred in a secondary coil. So the secondary coil, the magnetic field is increasing. When the magnetic field is increasing, induced current in a secondary coil also is going to increase. When the flux increase, the current will be increased, okay. After some time, the current is become as a saturated maximum level, flux is become as a constant, so there is no increase, decrease flux, the current, induced current is going to be 0, the galvanometer shows in a 0, okay. When we remove this plug key, the flux will be getting decreased, okay, the flux is going to slowly will be decreased. So now the changing magnetic field is there, decreasing magnetic field is there, so the current is going to be a opposite side direction. Again we'll see the question, see here, the later the key is inserted, then he removed shortly, okay. What are the two observations that can be noted from the galvanometer? So when we inserted, the flux will be increased, current is showing, the galvanometer will be deflect as the one side. When the current is maximum saturated level, okay, the current is going to be 0. When we removed the plug key, the current is going to show in a opposite direction, okay. Two observation they asked, okay. When we inserted, when the maximum level is there, the current will be 0. When we take out, the current will be flowing in a opposite direction. That is the answer for 7th one, okay. Again I am going to do with the 8th one, draw the magnetic lines around the straight wire current carrying conductor. Which one is very easy, we are taken as a straight wire current carrying conductor, only you have to use the right hand thumb rule. So right hand thumb rule like this, your finger will be representing current direction, your thumb will be representing current direction, your finger will be representing as a magnetic field direction. So current will be this side, magnetic field will be this side, circular magnetic field is produced, okay. Otherwise you can draw this way also, the magnetic field will be like this, okay. So circular current, magnetic field and straight conductor, okay. When the current increase, magnetic field will be increasing. The thing is, draw the magnetic lines around the straight wire current carrying conductor. This is for 1 mark, okay. Again, the next thing, two equal resistance connected in parallel, so like this they connected R1, R2, so two unequal resistance. If you are not provided with any other parameter, that means current, resistance, and nothing is provided, so what you can say about the voltage drop? They asked only voltage, it's very simple question. So voltage in parallel constant, so same R1 and R2 have the same voltage, okay, and there is no voltage drop, that's it, okay. Next question, some work done, the charge is given, the charge is bringing from infinity to 1 point. So infinity to 1 point means it's going to be potential, so the potential of the point A is given as the V. What is the work done to the moving charge? So voltage is equal to work done by charge bringing from infinity to 1 point. It's going to be a potential. So they asked what is the work done? Work done is equal to volt into charge, otherwise charge into voltage. So this is the answer for this, okay. They asked Q, V and work done relation. What is the work done to move the charge from infinity to in a terms of QV, infinity to 1 point, from infinity to 1 point, it's going to be a potential. So potential difference means 1 point to another point, it's a potential, the charge is bringing from infinity to 1 point. We can take it, this is a potential, formula is the voltage is equal to work done into charge, okay. This question number 9 is over. Again, only we are discussing in a sample paper, only physics question paper. Sample paper is, you know already, it is a very important sample paper discussion. Okay, the another long question is given, question number 20, comprehension, which is the physics question, is given in the 1 mark. Okay, so it is a big comprehension question, and here they are given the graph B versus I. Current, magnetic field versus current is given. The graph is given, magnetic field versus current, magnetic field versus current. Okay, so it is a straight line. We know already, according to the Faraday's law, current is directly proportional to magnetic field. When the current is increased, magnetic field will be increasing in a solenoid coil. Okay, the question is, first question, type of energy conserved, conservation is observed in a solenoid coil. So solenoid coil usually will be convert the electric field to the magnetic field. Okay, so the answer also will be electric field to magnetic field. I have a small doubt about this question. Okay, so next question, what will be happen if soft iron core is placed inside the solenoid coil? Soft iron core is a ferromagnetic material. Soft iron core is a ferromagnetic material. Okay, when we are placing the ferromagnetic material in a solenoid coil, okay, the magnetic strength will be increasing. Okay, it's going to behave as, when the current is increased, magnetic field will be increased. When the current is stopped, magnetic field will get stopped. Okay, when the current is decreased, magnetic field will be decreased. Okay, it will be act as a electromagnet, and also it is a temporary magnet. Okay, so this is the behavior will be happen. The option is given, the bar magnet will be electrodes resultant in a short circuit. It's not going to happen with short circuit. Okay, the bar magnet, the bar is the magnetized as long as there is a current in a circuit. Okay, so magnetized as long there is a current in a circuit. If we remove the current, the magnetic field will be getting decreased. Okay, maybe this answer will be correct. The bar will be magnetized permanently. I said soft iron core is not going to be behave like that because it's a ferromagnetic material. The bar will not affected by the any meanings. Okay, so that means this is our option. The bar will be magnetized as long as there is a current. When the current is stopped, there is no magnetic field will be there. Okay, the next thing, magnetic lines produced inside the solenoid coil is similar to dash. Already we know solenoid coil, it's same, its behavior, everything is a bar magnet, but it is a temporary magnet. Okay, so the magnetic field and all the properties will be the same, except this is a electromagnet and it is a permanent magnet. Okay, so solenoid coil will be behaving as a it's a bar magnet. Okay, this question is over. 20th question, the next one we are going to do it. Remaining all the answers will be wrong because already we know it does not depend any other thing. So solenoid coil, inside the solenoid coil, the magnetic field equivalent to the bar magnet. So it is a uniform. Solenoid coil, the magnetic field inside the solenoid coil will be uniform, or bar magnet, north to south, inside the magnetic field will be the uniform. The next thing, after analyzing the graph, so this graph, after analyzing this graph, so what is the conclusion we'll get? Okay, so magnetic field produced inversely proportional, just I will be given with the answer what is given. Magnetic field inversely proportional to the current, magnetic field is directly proportional to the current, magnetic field is directly proportional to squaring of current, magnetic field is not depend on the current. Okay, it's not depend on the current. As I said, from the graph, magnetic field and current will be directly proportional. That is the reason we'll get as a linear graph. So B versus I will be directly proportional. So this option will be correct. Only second option, D, is the correct. Okay. The next thing, from the graph, which statement is correct? So 0.8. So 0.8. So straight to that we'll check it, what is the magnetic field we are getting. So 0.8 I have here. Okay, straight to that magnetic field I have the 13 we have, and milli Tesla. Okay, 13 milli Tesla, meaning is milli Tesla is 10 power minus 3. So 0.8 we got as a 13 milli Tesla. This is the correct answer. The second answer, we have to check it, the large current. Okay, the magnetic field increases non-linear. It's not, it's wrong, it's a linear graph. Okay, 0.8 ampere will get as the current as the 13 milli Tesla. It is a wrong answer. We got 1.3 milli Tesla. It's wrong. There is not enough information to find this value. Actually, we had enough information. So the option will be A. We got the correct answer. A is 0.8 ampere is going to be 13 milli Tesla. Okay. The next we are going section B. 25 question, which is again it's a physics question, it's a prism question, it's a very easy question. See here, when the white light is going to come, okay, so this is the light path, the red is get deviated, violet is get deviated, red deviation least and violet deviation most. Okay, violet deviation most. So why this was happened? Maximum that will be one of the question. What is a phenomena and what is the reason violet deviate most? Okay. So I'm going to give you what is answer key is saying and also my other information. First we will see what is the phenomena. What is the phenomena means what is the process is called. This process we can call it is dispersion of the white light. When the white light is splitting into 7 color, which one we are going to call V, I, B, G, Y, O, R. It is a polychromatic light. It is going to become as a colored spectrum. So which one the phenomena we can call it is dispersion of white light. So what is a phenomena? It's a dispersion of white light. Which one is going to be given as 2 mark. Okay, first mark is for dispersion. What is the reason violet light bend more than the red? Okay, why the violet light is bent, the deviation of violet is more than the deviation of red. This is another question they asked in the same question. Okay, the deviation of red deviation of red is least than violet. That means violet will be more deviation compared to this place. Okay, so this is V, so deviation of violet, this is red, deviation of red, so deviation of red will be less compared to the deviation of violet. Okay, so why violet is most? Because the velocity of the violet is compared to the red. The velocity of the red will be travel faster in glass, the velocity of the violet will be travel slower in glass. Okay, otherwise wavelength of the red is compared to the violet, wavelength of the violet it is more, wavelength of the red will be more. Okay, you can give any two statements. So you can give red travel is faster in the glass, violet travel slower in the glass. Otherwise the wavelength of the red is greater than the wavelength of the violet. That is the reason the red will be deviation least compared to the violet. Otherwise deviation of violet will be most, because violet will be travel slower in the glass. That is the reason when the light is traveling, the red will be travel fast, violet will be traveling slow. That is the reason we will getting violet deviating more than the red. Okay, so we got this answer also. This is a electricity question. Which one is again one more easy questions. Okay, they asked this resistance is 4 ohms. Okay, and this resistance they don't know, R2 resistance they don't know. Okay, and they applied the battery is 12 volt, the battery plus minus 12 volt. Okay, the question is asked the current is flowing as a 9 ampere, current is flowing in this circuit 9 ampere. What is R2 resistance? R2 resistance is a 2 ohms or 3 ohms. That is a question is asked. Okay, the student has 2 resistors, 2 ohms and 3 ohms. Which is suitable to put here? R2 is which resistance? 2 or 3? Which one? Okay, when we are connecting as a resistance here, the current has to flow 9 ampere. Total current is flowing in the circuit 9 ampere. Okay, they asked calculate the it is a which of the two has to be choose from the student. Okay, whether it is a 2 ohms or 3 ohms. So whichever I am connecting, the current has to flow 9 ampere. Okay, so just we'll see. First I am taken as a 2. We'll check it. Okay, so this 2 in a parallel, 1 by 4 plus 1 by 2, I'll get as 1 by 4 plus 2 by 4. So just I am taken as total resistance. 1 by Rp is equal to 1 by R1 plus 1 by R2. So I'll get as R1 as 4 ohms, R2 as 2 ohms. Just I am taken common LCM. So we'll get 3 by 2. So 1 by Rp. So Rp is equal to 2 by 3. Sorry, 4 by 3, 4 by 3, 4 by 3, because we have here just flip the equation. So I'll get 4 by 3 Rp. So current is flowing as 9 ampere. So current has to flow 9 ampere. Voltage is 12 volt. Voltage is 12 volt. Current is equal to V by R. So I want current V is equal to IR according to Ohm's law. I is equal to V by R. V here it is 12. R is 4 by 3. So this is going to be 3. So 3 I am taken numerator, will get as a 9 ampere. So current is flowing as a 9 ampere. So that means here as I have to connect with 2 ohms. That means no need to calculate with 3 ohms, because it's 2 marks. Only one calculation is enough. I think first answer if we got. If we are not getting first answer, definitely we should do with the second also. Okay, the answer for here it is 2 ohms. Then only the current will be flowing in this circuit as a 9 ampere. Okay, so next question. 33 question. Okay, they are given refractive index of water with respect to the air, diamond also with respect to the air. Okay, water with respect to the air. So I got as 1.33. So refractive index of water with respect to the air. The light is traveling air to water. It's called 1.33. Refractive index of diamond. So A to D. We'll take it. It's 2.42. It's very simple question. In which medium does the light faster whether it is a water or diamond. So we'll know diamond is optically denser. Okay, so that means velocity of the light in a water, velocity of the light in a water, so velocity in a water will be faster. The reason it is optically weaker. Okay, the another formula you can give, mu of a to w is called v1 divided by v2. The first medium is c, second velocity of the light in a air, the second medium velocity of the light in a water. So this and this is inversely proportional. Okay, refractive index of water inversely proportional to the velocity of the light in a water. Okay, so refractive index and the velocity will be inversely proportional. As we know, velocity of the refractive index of water and refractive index of diamond. So we know diamond is more than the water. It's 1.33. It is 2.42. This is greater. Refractive index of diamond is greater than the water. So that means the more refractive index, the velocity will be less, because refractive index and velocity will be inversely proportional. If you are taken 1 to 2, v1 divided by v2. So velocity of diamond inversely proportional to velocity of the refractive index of diamond inversely proportional to velocity of the light in a diamond. Okay, so velocity and refractive index inversely proportional. More refractive index have less velocity, less refractive index have more velocity. Okay, so velocity of the light in a water is greater than the velocity of the light in a diamond. It's very simple question. So velocity of the light in a water will be greater. So that means this answer, water, is the exact correct answer. The next question, what is the refractive index of diamond with respect to the water? So as we know, it is they are asking diamond with respect to the water. So second medium is diamond, first medium is the water. So refractive index of A to D divided by refractive index of A to W. It's 2.42 divided by 1.33. Okay, so as we know, n1 to 2 is called n2 divided by n1. The same formula I wrote like this. Okay, so if you want to simplify this, 2, 4, 2, just multiple numerator and denominator 100, you, this will be remove the decimals. Okay, this division easily you can calculate, and the refractive index we don't have any unit, so you can write as a no units. Okay, so now we got this answer. The first option is water. Second option, diamond with respect to the water, just you have to divide this divided by this. So this divided by this, you will get the what is the answer. Okay, then we are going with the next question. Yeah, 36 question is 5-mark question. Okay, actually the circuit is in a parallel connection. Okay, so the circuit is in a parallel connection. So they asked 4 questions. Okay, the first thing is A, B, C, D. Okay, A, B, C, D, everything is in a parallel. The voltage is applied is in a 60 volt. Okay, the battery is applied in a 60 volt. Okay, so first I am going to teach you this circuit is in a parallel circuit. What kind of combination of the lamp are arranged in? It is a parallel. Okay, so the second question, explain with the reference of the above answer what is the advantage of any two advantages. Parallel circuit. Okay, advantage will be voltage is constant. Parallel circuit voltage is constant. The second thing, resistance will be less resistance. So the two things you can take it. So voltage is constant, V will be constant, and its resistance is less. Okay, the another advantage, if one circuit is getting spoiled also, other will be working properly. The another thing, each one have the own fuse. Okay, so they asked only two, you can give less resistance, voltage is a constant. Okay, the second explanation. Okay, so third I'll explain later. The fourth question, find out the total resistance. Okay, so finding the total resistance, it's very simple. Find total current. Okay, total current according to the total current, I have taken this as I total, I1, I2, I3, I4. The total current I am going to add as a I total as a it is 3 plus 4 plus 5 plus 3. So I'll get as a 15 ampere. Okay, the actually last question, find out the total resistance. Total resistance. Okay, I know total current is a 15 ampere. Okay, total voltage in this circuit is 60 volt. So they want what is the total resistance. Resistance is equal to V divided by I according to the Ohm's law. I is equal to V divided by R. So V is equal to IR according to Ohm's law. Okay, I is equal to R is equal to V divided by 60 divided by 15. So I'll get as the resistance as the 4 ohms. So resistance, the total net resistance will be 4 ohms. Okay, if you required, I will be teaching with each resistance how to find the each resistance. Okay, R1 resistance, first in parallel voltage is constant. Already I said first R1 resistance is equal to V divided by voltage is constant, V divided by I1. So V is 60, I1 is 3. So we'll get 20 ohms. R1 as 20 ohms. Okay. R2, the next calculation here is the R2. So R2 is equal to V divided by I2, that is called 60 divided by 4, which one we are going to get as the it is 1 and it is 15 times. Okay. So 15 ohms. R3, 5. So it is V divided by I3, 60 divided by 5. So we'll get as a 12 ohms. Again R4, V divided by I4. So V is 60, I4 is the 3 ampere. So V divided by 3 will get as the 20 ohms. So I got what is the resistance. This everything is in a parallel. So you can find 1 by Rp is equal to 1 by R1, 1 plus 1 by R2 plus 1 divided by R3 plus 1 divided by R4. This value is equal to, already we found resistance in parallel, which is going to resistance, total resistance is 4 ohms. Okay. You can do either or method. Okay. The next question. Next question from electromagnetism, which one is a new question that this year they asked in a sample paper. Okay, this is a question. So when the current is flowing in a straight wire, okay, when the current is flowing in a straight wire, so P and S and R, we have 2 points. S is here, R is here. Okay, S is here, R is here. S, R. So S is closer, R is a little long distance. Okay, they asked question. Find the diagram, direction of the magnetic field produced by the point R and S. Current is moving up. Okay, current is moving up. Right hand thumb rule. So yes, the current will be coming outwards. Okay, coming outwards, or the current will be entering into the node. Okay, it is outside and it is inside. So it is R point inside to the paper, S point outside to the paper. One question over. Find out the direction of magnetic field produced by the point R and S. I use right hand thumb rule. Current is upwards. Magnetic field is flowing like this. From S is coming out. R is going towards. So I got this question. Give R1 is greater than R2. R1 is greater than R2. Find that from the diagram we know R1 is greater than R2. Is given in statement also. Where will be the strong magnetic field be large? Give the reason. So in R1 is in the magnetic field is S greater than the magnetic field in R. Okay, just B is a magnetic field. So magnetic field in the point of S is greater than the magnetic field in the point of R. The reason, it is closer to the wire. S point is closer, R point is little long distance. That is the thing. So here magnetic strength will be greater. The point is over. The second one, the strength is closer, S point, the magnetic strength is longer. Okay, again, if the polarity of the battery is changed, if the polarity of the battery is changing, meaning they are switching the battery opposite side. Okay, so now what is the would be the direction of the magnetic field be changed. Okay, so when the polarity is changed, before it was current is flowing Q to P, now the current will be flowing P to Q, opposite direction, so downwards. Okay, now S is here, R is here. So how the current will be flowing? Okay, so this will be coming as it's coming out and it's going in, opposite to that. It is outside and it's going inside. I use right hand thumb rule. So like this. Okay, like this we can use. Okay, so my thumb is representing current direction, finger is representing magnetic field. So in this point, finger is exactly entering into the paper. So you can tell here it is inside, here it's coming outwards. Okay, so here R point coming outside, opposite to that S point going inside to the paper. Explain the rules which is used to find the direction of the magnetic field straight current carrying conductor. I use the right hand thumb rule. Right and thumb rule. So why we are using this rule? Thumb is representing as the current and finger is representing as the magnetic field. Okay, this what we have to do it. Okay, the next thing, question number 19. So another question which one I left that I am going to discuss. Question number 19 from the section A. Okay, it's actually comprehension question. It is made up of compound telescope. Okay, then it is actually out of syllabus for your, according to your age. It's look like out of syllabus. Actually, it's not out of syllabus. It is your syllabus only. They asked as a very simple question from the comprehension. Okay, so you have to read all the statements. Okay, so which one I will consume 2-3 minutes. You have to read it. Okay, so unless otherwise, if you don't know concept, you have to read full paragraph. Okay, first we'll see the construction. Okay, first question. Okay, from 19, it's a 1 mark question. Based on the diagram shows what kind of lens. So diagram shows what kind of lens is used. Okay, so it is a convex lens. So that is the thing. So it is a convex lens. Okay, so the option B is the correct answer. Bifocal length, this and all is different, flat lens and all is different, so we are using as a convex lens. There are two convex lens, don't get confused, it's not a bifocal length is different than the convex lens. Otherwise we can write the same word is in a biconvex lens. Okay, so don't go with the bifocal length. Okay, so the thing is we are using as a convex lens. Okay, two lenses is there, both is convex lens. The power of the lens 1 and lens 2 ratio is 4:1. Power is 4:1. Power 1 is to power 2 is a 4:1. They asked what is the focal length. The power is inversely proportional to focal length. Power 1 divided by focal length. Power 2 is equal to 1 divided by focal length 2. So power 1 divided by power 2 is equal to 1 divided by focal length 1 divided by 1 divided by focal length 2. So you have to bring it like this. So f2 divided by f1. So we got this ratio is 4:1. So power 1 is 4, power 2 is a 1. So opposite to this is a 1:4 ratio, because power is inversely proportional to focal length. So we got it is 4:1 means the focal length will be, lens focal length will be 1:4. Okay. The other question, magnification we know v divided by u, so that means the ratio of v divided by u, otherwise h2 divided by h1. So the ratio of height of the image to the height of the object. So no need to read another thing, just directly we got the answer. The question number 19. Question number 19, they asked what is the distance of the object. What is the distance of the object? Okay, that means u is the question mark. So m is given in this particular question is 3 and image is 24. So m is 3, v is 24. What is u? M is equal to v divided by u. So they asked what is u. So u is equal to v divided by m. I know it is 24, it is a 3. So we will get this as a it is 8. So 8 3s are 24. So 8 centimeter as the final answer. The next thing, so the she brought as a not a so thick lens of the telescope. So why, what happened? Because would not make the telescope as a very heavy. Okay, that is the reason she is not used as a thicker lens, and also allow considerable amount of the light passes through. It's a very limited purpose only. That is the reason she bought as a not so thick lens. Okay, that also another answer. Thank you, Pa. Thank you everyone. If you like my channel, please subscribe. Thank you everyone.